Surface waves are of two types. One is, yes, great, thank you. L waves and R waves. Okay, so this is what we are going to do today. Okay. One second, I'll post a picture of this. Sorry, oh my God. Wait, 1 second. Posting a wrong group. I'm doing a lot of wrong group posting here, there. Okay, I'll post it later after class. Okay, so now our whole lab will be based on P wave. So P waves comes first, then is the S wave. And if you remember from our last week's assignment, what we have done, that P wave travels first, okay, then the S waves. And also just remember that here, if it is a ground surface, from the epicenter, right, from the epicenter. So if this is the epicenter, if this is the focus, right, or hypocenter, waves travel to the epicenter. Okay, so it reaches the epicenter the first. Okay, it reaches the epicenter the first. All right. Okay, so if there are 3 stations, please listen very carefully. Suppose this is station X, this is station E, this is station Y. So the waves will reach E the first. So the waves which reach the first is the epicenter. So always we want to find out the epicenter. You know why? Why we want to find out the epicenter? We want to find out the epicenter because we know that below the epicenter, the earthquake has originated. Because we know that below the epicenter, the earthquake has originated. That's why we don't know where earthquake has originated, but we want to find out where exactly in the plate boundary did it start. So in order to find that out, we have to find out the epicenter first. The epicenter guides us to find out the focus or hypocenter. The epicenter guides us to find out the focus or hypocenter. Okay, so because we are all in the surface as scientists, so we don't know which place in the under 200, 300, 4,000 feet below the Earth's surface, we don't know where earthquake has started. We don't know. But if we can find out the epicenter, that will be today's lab. So listen carefully. If we can find out the epicenter, boys and girls, then for sure we know that we can find out the origin of the earthquake, and that is our plan, that we want to find out where earthquake has originated. Is it under Los Angeles? Is it under Mexico City? Is it under Las Vegas? Where has it originated? Now all these cities I named is in the west coast. All these cities I named is in the west coast. You know why? Because west coast of America is in the plate boundary between the Pacific Ocean and the North America. So it is between the North American plate and the Pacific Ocean plate. North American plate and the Pacific Ocean plate. Okay, that's why this is very important. North American plate boundary, North American plate and Pacific Ocean plate. So that area is very, very vulnerable to earthquake. Whereas New York is not vulnerable to earthquake because we are not in a plate boundary. Rather, we are in a We are away from a plate boundary. The plate boundary is in the middle of Atlantic Ocean. All right. So having been said all these things, let's start our lab. 1 second. So all of you open your lab first, okay? Let's read it. What's an earthquake? And who is going to read it now?
What do you want us to read, Professor?
Yes. What is an earthquake? First, you start. Anybody who can start reading?
I'll read.
Okay, sure.
What is an earthquake? Earthquakes occur because of a sudden release of stored energy. This energy has built up over long periods of time as a result of tectonic forces within the earth. Most earthquakes take place along faults in the upper 25 miles of the Earth's surface, when one side rapidly moves related to the other side of the fault. This sudden motion causes shock waves. How do you say that? Seismic waves to radiate from their point of origin, called the focus,
I'm
and
sorry. I was muted.
travel.
It's called seismic waves. Yeah.
Seismic. Okay, sorry. And travel through the earth. It is these seismic waves that can produce ground motion, which people call an earthquake. Each year, there are thousands of earthquakes that can be felt by people, and over 1 million that are strong enough to be recorded by instruments. Strong seismic waves can cause seismic waves can cause great local damage, and they can travel large distance. But even weaker seismic waves can travel far and can be detected by sensitive scientific instruments called seismographs.
Thank you, Celine. Who will be our next volunteer to read what are earthquake or what are seismic waves? Who can read it? Who will read it? Come on, don't waste time. We can finish. Yes, Brandon. Seismic waves. Yeah. What are earthquake waves are called seismic waves. So question. So yeah. Seismologist. Seismologist. Yeah. So this is very important. Like 1 second, Brandon. I'm sorry to interrupt you. This is very, very important. Just remember, like through the EKG, cardiologists or doctors can understand what is going inside your heart. So these seismic waves, geologists and scientists understand what is under the earth. Is it under California? Is it liquid, solid, or gas? So when they get P wave and S wave, both, they know it is solid. When S wave is missing, they know it is not solid because S wave S wave only travels to solid. So if S wave is missing, they know it's not solid. Then they will know, oh my God, this area underground is not solid. It is either liquid or gas. So this is how they find out a picture of under the earth. Yes, Brandon, carry on. Thank you. Thank you very much, Brandon. So we understand that P wave and S wave, the character